So moving on to question 3 from the Further Pure Maths to Edexcel. So this question is a question on recurrence relations. There's a lot going on in this question, so make sure you read the question thoroughly, guys, especially for these recurrence relations ones. There can always be a little bit of information that you might need from the detail given up here, so always read through it thoroughly. And part A actually requires you to read through, and pick out why certain parts of the information is given. So we're given this recurrence relation here, where the next term in h is given by 0.97 times the previous, hn, plus 0.15, where h1, the first term, is 6, and n is just any positive integer. So we have to explain in the context of the problem why the height of the tree may be modelled by this recurrence relation. Well, I've written it down up here just to save time, and just because my writing is just really neat. But basically, you've got to mention these 3 points. So 3 marks, each one gets you a mark. So the first one is that hn is the measured height at the start of year n. So that's your first term like that, right? And it decreases by 3% at the start of year n, which is given here. It's trimmed by 3% of this height. Well, if it's trimmed by 3%, that's just the same as handling it by 0.97 hn, which is where we get this 0.97. So that's your first mark for just mentioning that. h1 is equal to 6 is the height of the tree at the start of year 1. So this is just what you're given here. On the first day of year 1, the height is 6 meters, and this is where the h1 equals 6 comes from. And then we also have to mention briefly about this 0.15 here. Well, it does tell you here the tree is known to increase in height by 15 centimeters each year. Now it tells you the height is 6 meters. Well, if the height is 6 meters and we're adding 15 centimeters each year, that's 0.15. So that's your addition of 0.15. And mentioned here, 0.15 is added as this is the increase in centimeters each year. So that's part A done. So let's get rid of that. Let's start with the maths side now. So for the first bit of maths here, we've got to prove by induction this recurrence relation. So how do we do this? So part B. Well, remember, for any proof by induction, we have to start with the base case. N is equal to 1. So N is equal to 1. What do we get? Well, we're going to put it into this part here. So what will that give me? That's going to give me 0.97. Well, if N is 1, that's 1 minus 1 plus 5. So that's 0.97 to the power of 0 plus 5. Well, that's just equal to 1 plus 5, which is equal to 6. Well, h1 is 6. Perfect. It's true for n equals 1, right? Where do we go next with the next inductive step? Well, we assume it's true for n equals k. So we assume true. Let me just write AT. So assume true for n equals k. Well, how do I do this? Well, if it's equal to n is equal to k, let's take it back to this here. So that gives me hk is equal to 0.97 to the power of k minus 1, so then just replace it with a k. So that's the power of k minus 1. And I've still got my plus 5 here, so let's add that on. Plus 5. Alright, we've got hk. But now, we need to, think about proof by induction. The next step is we plug n equals 1 into here. Or k equals 1, sorry, k plus 1. So if we plug k plus 1 into here, well, that'll just be the same as putting k in here, right? Which is what we've done here, but with this part of the equation. But we're going to put it in here and let's see what we get. So h of k plus 1. H of k plus 1. Well, that's going to be equal to 0.97 times h of k. Well, we've just worked out h of k here, so let's do that. So that's 0.97. So I won't write out the full expression yet. I'm just going to write it as h of k so you can see what's going on. Wherever there's an n, we're replacing it with a k. So hk plus 1 is equal to 0.97 hk plus 0.15 plus 0.15. Let's keep going with this. We know hk is this. We're going to substitute in. So that's going to give me 0.97 times this expression here. So that's 0.97 times this expression. So this is going to get a little bit messy. 0.97. So I should have put this in a second bracket like that to the k minus 1. And I've still got my plus 5 from here, because it's the full expression of hk, so plus 5. And I've got my plus 0.15 at the end. Plus 0.15, like that. There we go. Now we're going to expand this. Well, if I've got 0.97 times 0.97 to the k minus 1, all that's going to be is 0.97 to the power of k. Like that, right? 0.97 times 5, well, that's going to give me plus 4.85. Obviously, just make sure you're doing these on your calculator. Plus 4.85. Plus 4.85. Well, plus 0.15 as well. What's that going to give me? That's going to give me plus 5. Perfect. That's exactly what we wanted. So we've shown now that this is equal to 0.97 to the k. I should probably put it in a bracket, but I'm just being a bit lazy because that's what we do. Plus 5. And there you go. You have now proven by induction that this is true. So remember, guys, for a proof by induction, you've always got to finish with that last statement where you say, it's true for n equals k, assume true for blah, 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 and keep going. I will write in the description just a little sentence that you need. It will cost you a amount if you forget it, so just make sure you don't forget it. Part C, we can just do it over it. It's just a short one. Explain what will happen to the height of the tree immediately before trimming the long term. So it's just one mark, and you just need one sentence. All you're actually going to say is that the height will approach 5 meters. So I'm going to put h here. Approaches 5 meters, and that's all it is for one mark. So hopefully that's okay. And then part D, by what fixed percentage should the tree be trimmed each year if the height of the tree immediately before trimming is to be 4 meters in the long term? So there's a lot of trimming going on here, so be careful not to get confused with what's actually being asked of you. All we have to actually do is set up an equation. Well, we want the height before trimming to be 4 meters in the long term. So what I've actually got here is this equation. It's going to be 4x plus 0.15. So plus 0.15. Well, that's going to be equal to 4, right? So that's going to be equal to 4. This is just a really basic equation. We've just got to solve it. So that gives me 4x. That's going to be equal to 3.85. 3.85. Divided by 4, so therefore x is equal to 0.9625. But be careful, this isn't my percentage. My actual percentage is going to be 1 minus this. So if I do 1 minus this, so therefore 1 minus x gives me 0.0375. Which is 3.75%. Make sure you give your answer as a percentage. And there you go. That's what we were looking for. We're looking for that fixed percentage. So remember, it's not this here, but 1 minus this. Similar to how we did it here. It's not, we're not timing it by 0.03. It's 0.97. It's similar here. Just the same idea. Just make sure you do 1 minus that. So I hope that's okay. It's quite a long question, but go through it again and check out the other videos from this exam paper if you need help, guys. They'll all be on my channel very soon.